Hi everyone. Today we're going to study Hasse diagram. A Hasse diagram is a graph for a partial ordering that does not have loops or arcs that imply transitivity and is drawn upward, thus eliminating the need for directional arrows. The partial order is reflexive at every vertex in the Hasse diagram, or digraph of a partial order, such that there would be a cycle of length 1. In view of this, while drawing the Hasse diagram, we need not exhibit such cycles explicitly. They will be automatically understood by convention. If there is an edge from vertex A to vertex B, and there is an edge from the vertex B to vertex C, then there should be an edge from A to C because of transitivity. As such, we need not exhibit an edge from A to C explicitly. It will be automatically understood by convention. To simplify the format of Hasse diagram, we replace the circles representing the vertices by dots, and to draw in such a way that all edges point upward, with a convention that all edges point upward. We need not put arrows in the edges. Hasse diagram is also called poset diagram. Example 1. Let set A with elements 1, 2, 3, 4 and relation with ordered pairs 1, 1, 1, 2, 2, 2, 2, 4, 1, 3, 3, 3, 3, 4, 1, 4, 4, 4. Write down the Hasse diagram of relation R and R inverse. Note that the given relation here is a partial ordering, which means it is reflexive, it is transitive, also anti-symmetric. Now let us draw the Hasse diagram for R. Let's begin with this 1, 1. We write a dot with number 1. This 1, 1 now is represented by this dot alone. Then we go to 1, 2. Remember that edges are drawn upward. So we have this dot number 2 connected to dot 1. Then we have this 2, 2, and this dot 2 here is enough to represent this 2, 2. Then we have the 2, 4. So we connect dot 2 with dot 4. Then we have 1, 3. We will now connect dot 1 by dot 3 and the 3, 3. This dot 3 here is enough to represent this 3, 3. Then we have 3, 4. We connect 3 by 4. Next is 1, 4. There is a way that connects dot 1 to dot 4. It can be from 1 goes to 2, then to 4. Or 1 goes to 3 and goes to 4. So this would be enough. Then we have the 4, 4. This dot 4 here is enough to represent the 4, 4 ordered pair. Then we have this R inverse. We can write the ordered pairs for the R inverse in this way. And in writing the Hasse diagram for the R inverse, we will just take the R diagram that will be turned upside down. So it becomes like this. The number 1 comes up and the number 4 comes down. The dots 3 and 2 remains on the position. This is now the final answer, the Hasse diagram for R and the Hasse diagram for R inverse. Example 2. Let set A equals 1, 2, 3, 4, 12 elements. On A, define the relation capital R by A R B, if and only if A divides B. Draw the Hasse diagram of R. Note that R is a partial ordering here. It is reflexive, meaning any element can divide by itself. It is transitive. Let us see one example. If 1 divides 2 and 2 divides 4, it means 1 divides 4. Then we have antisymmetric. If 1 divides 2, then 2 does not divide 1. Let us now draw the Hasse diagram. Let's begin with the smallest element, that is 1. We have here the dot 1. Then we have the 2. We connect 1 by 2. Remember, we draw the edge upward. Then we have the element 3. We connect 1 by 3. There is no connection with 2 and 3 because 2 does not divide 3. Next, the element 4. This 4 can be divided by 2. So we connect that 2 by 4. Next, we have the element 12. This 12 can be divided by 4 and 3. So we have now the dot 12 connected to both 4 and 3. This is now the final answer. For additional information, we wrote here the elements of the relation. Example 3. Draw the Hasse diagram of positive divisors of 36. We write here the D sub 36, meaning the divisors, and these are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Note that D sub 36 is a partial ordering, meaning it is reflexive. Any element can divide by itself. It is transitive. If 1 divides 2 and 2 divides 4, it means 1 divides 4. It is antisymmetric. If 2 divides 4, therefore 4 does not divide 2. Let us now draw the Hasse diagram. Let's begin with the smallest element, dot number 1. We connect these to dot number 2. We draw the edge upward. Then the third element is number 3. We connect dot 1 by dot 3. Next element is 4. This 4 is connected to 2 because 2 divides 4. Next element is 6. The number 6 can be divided by 2 and 3 respectively. So we connect the dot 6 into the dots 2 and 3. Then element 9. This 9 will be connected to dot 3 because 3 divides 9. Next, element 12. The number 12 can be divided by 4 and 6. So we connect dot 12 by two numbers, 4 and 6. Next element is 18. This 18 can be divided by 6 and 9 respectively. So for dot 18, it is connected to dot 6 and dot 9. The last element is 36. This can be divided by 12 and 18 respectively. So for dot 36, we connect it to dot 12 and dot 18 respectively. This is now the final answer. This is the Hasse diagram.